Good morning/afternoon, everyone. I'm excited to welcome you to this presentation on understanding behavioral data graphs in applied behavior analysis. Today, we'll be exploring a comprehensive guide covering the different types of graphs, their key components, how to analyze them, and best practices for monitoring behavior effectively. Whether you're new to ABA or looking to sharpen your skills, this session will provide valuable insights to help you interpret and utilize behavioral data with confidence. Let's dive in. Behavioral data graphs are fundamental tools in applied behavior analysis, or ABA, because they allow us to visually track how behavior changes over time. They give us a clear and organized way to see patterns and trends, making it easier to compare behavior across different conditions or phases. This visual approach helps practitioners monitor progress accurately, ensuring that we can see whether interventions are working as intended. More importantly, these graphs support data-driven decisions, guiding us to adjust strategies based on solid evidence. Lastly, they play a crucial role in communicating findings clearly and effectively to stakeholders, ensuring everyone involved understands the progress and outcomes. Here we have three common types of behavioral graphs. First, line graphs. These display data points connected over time, which makes them really useful for showing trends and changes in behavior as they happen. Next, bar graphs. These are great for comparing discrete categories or conditions, so you can easily see differences in behavior levels across groups or settings. Finally, cumulative records. These graphs show the total number of occurrences accumulated over time, giving a clear picture of the overall frequency or count of behavior. Each type serves a unique purpose depending on what aspect of behavior you want to analyze. Here, we see the key components that make up a behavioral graph. First, the x-axis, which typically represents time or sessions. This gives us a temporal context, allowing us to track how behavior changes over a specified period. Next, the y-axis measures a specific dimension of behavior we're interested in, like how often a behavior occurs, how long it lasts, or its intensity. Then, we have the data points, each representing an individual measurement collected during the sessions. These points are connected by the data path, which is a line that helps us visualize patterns or trends in behavior over time. Finally, phase lines are vertical markers that separate different conditions or interventions. These lines highlight shifts between experimental phases, so we can clearly see how changes in conditions might impact the behavior being studied. Understanding these components is essential for accurately interpreting and analyzing behavioral data. When we talk about level in behavioral data analysis, we're referring to the average value of behavior within a particular phase on a graph. Think of it as a snapshot that shows the overall magnitude of the behavior during that time. By looking at level, we can easily see whether behavior is going up, going down, or stay about the same when we compare different phases. For instance, if the baseline shows a high level of behavior, and then the level drops during the intervention phase, this indicates that the intervention is likely effective. Understanding level correctly is crucial because it forms a basis for deciding if the treatment is having the intended effect. When we talk about trends in behavioral data, we're looking at the general direction and speed of behavior changes over a period of time within a given phase. An increasing trend means a behavior is consistently going up, showing steady growth. On the other hand, a decreasing trend indicates a behavior is steadily declining. And a stable trend means the behavior stays relatively the same with little to no change. Being able to recognize these trends is crucial because it helps us understand how behavior is evolving and allows us to predict what might happen next. The graphs here give us a clear visual way to identify and differentiate these patterns, making the analysis more intuitive. When we talk about variability in behavioral data, we're referring to how much the data points fluctuate or stay consistent over time. If there's high variability, it means behavior is quite irregular or unstable, which can make it tricky to draw clear conclusions. On the other hand, low variability shows that the behavior is consistent and steady. By evaluating this variability, we can better understand how reliable our data is and identify whether outside factors might be influencing the behavior we're observing. This step is crucial for accurate analysis and interpretation. Now, let's dive into how we interpret graphs with some practical examples. First, we'll look at behavioral data graphs and explore effective ways to analyze them It's important to focus on the baseline and intervention phases because comparing these helps us assess whether any meaningful behavior change has occurred. As we examine the data, we need to identify shifts in level, trend, and variability. These are key indicators that tell us that the behavior is truly changing. Lastly, phase lines are critical tools. They help us contextualize these changes by marking when interventions begin or end, making it easier to see how behaviors respond over time. When constructing effective behavioral graphs, the first key point is proper labeling of axes. This means including clear units and descriptions so that anyone looking at the graph understands exactly what is being measured and how. Next, appropriate scaling is crucial. The scale you choose should highlight meaningful changes in the data without exaggerating or minimizing those variations, ensuring an accurate visual representation. Then, precise plotting of data points is essential to avoid any misrepresentation. Every point needs to be placed carefully to reflect the true results. Finally, using phase lines is a great way to denote different experimental conditions on the graph, helping to make the data easier to interpret and understand at a glance. These elements together create clear, informative graphs that effectively communicate behavioral data. When creating graphs, there are several common errors that can significantly impact how the data is interpreted. First, incorrect scaling is a big one. It can either exaggerate or minimize changes in behavior, which misrepresents the true patterns. Next, mislabeling the axes or units can cause confusion, making it hard to understand what the data actually shows. Another issue is omitting phase lines. These lines mark important changes or interventions, and without them, it's difficult to see how these events affect behavior over time. Overplotting or having inconsistent data points can also reduce clarity, making the graph cluttered or misleading. The key to preventing these errors is careful review and sticking to established standards, which helps ensure our behavioral data analysis is accurate and reliable. To wrap up, let's review some key points. Behavioral data graphs are essential in ABA because they help us track and interpret behavior over time, providing a clear picture of progress. Each type of graph has its own purpose, tailored to different analytical needs. So choosing the right one is crucial. It's also important to understand the parts of the graph thoroughly. Knowing how to read and create them accurately is foundational. By analyzing aspects like level, trend, and variability, we gain a comprehensive understanding of behavior patterns. Finally, following best practices in graphing and avoiding common mistakes enhances the reliability of our data. Mastering these skills empowers us to make well-informed decisions, ultimately leading to better treatment outcomes and clearer communication within the scientific community.